What would happen if a nuclear bomb exploded on the moon? Instant light, extreme temperatures, and perhaps more than we can imagine. In a vacuum, there is no atmosphere, so there is no shockwave. But the temperature reaches 10 million Kelvin, almost like in the center of the sun. Energy dissipates according to the formula. E equals y4, pi r squared, E equals 4 pi r squared y. And even at 100 meters, the energy flow is deadly. But where does the energy go if there is no atmosphere? Straight into space, in the form of X-rays and gamma quanta. And all this is visible from Earth, in telescopes, a bright flash, like a supernova, but on the moon. Yes, the moon has no atmosphere. But what about dust? A cloud of molten regolith forms. Its particles evaporate, and this is important. Most of the ejected particles will not leave the moon, but some will exceed the second cosmic velocity, 2.38 kilometers per second. Particles that leave the moon become a potential threat to satellites. Their trajectories are unpredictable. On Earth, there is no noise, but in the radio range, we hear a pulse, an electromagnetic peak. From Earth, it looks like a supernova, but astrophysicists immediately see the difference, the spectrum of radiation. Although the explosion in a vacuum does not create a sound, it is accompanied by high-energy radiation, including a gamma-ray burst visible even beyond Earth. If you were standing on the moon in a spacesuit next to the epicenter, you would be vaporized in a nanosecond. There is no air on the moon, but a plasma cloud of vaporized material can exist for fractions of a second. A few seconds later, there was only a crater. The lunar regolith had cooled, leaving traces of isotopes and neutron radiation. But most importantly, you left a radioactive imprint on the moon that will be visible for millions of years. What if we use the bomb as a geophysical instrument? We can measure the seismic structure of the moon. The moon is seismically ringing after the explosion. This was already indicated by the Apollo experiments. On Earth, a seismogram would show a weak but distinct pulse, passing through the entire planet. By the way, this is an ideal way to test the structure of the moon's core, without drilling yet. But what about the implications for future missions? Radioactive soil equals danger. In theory, a powerful nuclear explosion could change the orbit of the moon. But by how much? The moon has a mass of 7.35 times 10 to the 22nd kilograms. To move it noticeably, you need energy comparable to the gravitational connection of the moon with the Earth. What if the explosion goes deep, under the surface? This will create an underground cavity like nuclear tests on Earth. Only without an atmosphere, there will be less collapse. An underground explosion leaves a lunar cave, perfectly sealed, filled with radiation. Science is great, but now seriously, what if the charge was megaton class? In this case, the crater will be several times larger, the melt will be deeper, and the radiation will go into orbit. The neutron radiation will cause the material in the soil to activate. The moon sand will become radioactive. In decades, this place will still be dangerous. Even in 1,000 years, it will be possible to find it by radioactive traces. And whoever did this will definitely find out. The moon doesn't forget. What if we use not one bomb, but 100 or 1,000? This could already affect the orbit. The moon will receive an impulse, slow but noticeable. Is it possible to tear the moon away from the Earth completely? Theoretically, yes. Practically, no. Any attempt to push the moon is a costly folly that leaves only radioactive scars. And all this for what? To prove that the moon has no atmosphere? We knew that, but now we know for sure.